Now how to differentiate this inverse trigonometric composite function? For that there is a formula. Can we solve this question using theorem of derivatives of inverse function? Hi everyone, welcome to daily practice. In this video I will explain you solution of the question that you can see on your screen. So I urge you to watch this video till end so that you will get complete understanding of each and every step involved in the solution of this question. If you face any doubt, you can share it in the comment box or DM it to me on my Instagram handle. Without any further delay, let's start solving this question. First, I will read this and understand what is given to us and what we have to find out. Differentiate with respect to x, cot inverse of x cube. We have to differentiate this given inverse trigonometric composite function with respect to x. Now how to differentiate this inverse trigonometric composite function? For that there is a formula. Which formula? Cot inverse of f of x is equal to minus 1 upon 1 plus f of x bracket square multiplied by f dash of x, which is equal to minus f dash of x divided by 1 plus f of x bracket square. Now if we compare this given function and the formula, then what we can conclude? F of x is equal to x cube, and derivative of this f of x is f dash of x, which is equal to derivative of x cube is 3x square. Now I know the value of f of x and f dash of x. Now I will substitute these values in the above formula. So what I will get? Derivative of cot inverse of x cube is equal to minus. Now this, instead of f dash of x, what I will put? I will put its value, that is 3x square. So 3x square divided by 1 plus f of x bracket square. So f of x is x cube and its bracket square. I will simplify this step further. Then what I will get? D by dx. Cot inverse of x cube is equal to this minus 3 inside the bracket 3x will give me minus 3x square divided by this x raised to 3 bracket square will become 1 plus x raised to 6. Using laws of indices, we have find this value, x raised to 6. Now as we cannot simplify this further, this is the final answer for this given question. Final answer. So I hope you have understood each and every step that I have used. If that is the case, then give this video a thumbs up, share it with your friends, and don't forget to subscribe the channel. Can we solve this question using theorem of derivatives of inverse function? If yes, try it, and whatever the final answer you get, compare it with our answer that we have obtained in this video solution. If both are same, then your answer is correct. That's it for this video. See you in the next video. Till then, keep practicing.